Hello, everyone, and welcome to another virtual IoT meetup. My name is Serena, and joining us today we have Mary. She'll
Mm.
be discussing the benefits of MQTT for IoT apps and beyond. If you have any questions for Mary as we move through today's presentation, feel free to ask in the chat, or you can use the Ask a Questions tab. Without any further delay, Mary, over to you.
Thank you so much, Serena. Thank you to Eclipse Foundation. Really happy to be here today. So let me make sure I switch over to this. Yeah. Okay. So welcome, everybody. And actually, let me first also mute my phone. I always forget to do that. So, okay. So thank you. So topic is about MQTT, and it's really a bit of a highlight on the protocol itself too, and with a bit of example. So, but first of all, let me introduce myself. I'm currently a developer advocate, a senior level developer advocate at DataStax. I'm actually also a Java champion too. DataStax, too, by the way, is a company that specializes in big data. It's actually open source big data, so Apache Cassandra, cloud native enabled database as a service. And I'm actually specifically on the Pulsar, Apache Pulsar project, which is actually provides streaming for Cassandra too. So that's where I am. And I was previously at IBM, also briefly at HiveMQ, and that's when I worked on IoT on MQTT. I'm based in Chicago. And I'm also the Chicago Java Users Group president too. I also help out with a couple of IBM-sponsored meetup groups. That was actually more active before the COVID times, and unfortunately, because of COVID, the IBM ones have been a bit quiet. But if you're interested too, we're intending to kind of start up all those meetups again. So I'm really a big community kind of active like participant and organizer. And I have actually, before becoming an advocate, I've been a developer advocate for 4 years or so as a professional. And before that, I was a developer, software engineer for like over 25 years, and kind of on different topics. I work on products and also application design and architecture and implementations too at various companies that includes trading firms, trading market, and financial manufacturing, cell phone company as well, among other things. So, and then here's how a bunch of connections, how you can get a hold of me, but I'll share that with you again towards the end of this slide presentation. So thank you very much again. And if you want to actually join my Discord server too, you are always welcome to as well. I always respond to things. I just encourage more of an interactions, and you can meet other like-minded folks too. Okay, so for today, here are the agenda for today. So first, I'll talk about the IoT stack, and then start going into what is MQTT, a bit of history about it being a community-driven specification that's governed by the OASIS. And then we'll get a bit more then into the MQTT specifics, the 3.1.1 features, which are still kind of more widely adopted and implemented by different vendors at this point. Then there's also MQTT 5, and that actually introduces more complexity, more things, and more capability, right? More power, making it more powerful. That's in MQTT 5, which is a relatively newer version of the protocol. And then we'll talk a bit too about some alternative protocols. If you don't use MQTT, what are some of your choices? And then we'll highlight essentially the title of this talk is about benefits and strength. So we'll kind of focus on that. And actually, I forgot to add a line in which we will also do a bit of a demo plus some example MQTT broker implementation, and from different organizations. So okay, so that's the plan. Okay, so first of all, let's kind of look at IoT. And please forgive me too. I have to assume that maybe not everybody coming in here are experts, right? And we can be expert in many other things, but you're curious too about IoT. You're coming in here, or you're a student, you're learning, and whatever that is, but that have brought you here. So thank you very much for being here. And so let's kind of put everybody on the same page, so then we understand where MQTT fits in this global picture of IoT. So the IoT stack, right, from 30,000 feet, like a high level thing. Let's take a look at it. Actually, for me too, when I was at HiveMQ briefly too earlier this year, I kind of went in with more of an expectation of, okay, now I'm going to work with Raspberry Pi. I'm going to work with the sensors and actuators. Yes, true, of course, yeah, there are that level of kind of specifics, right? We need to collect data. It gets into these physical, devices. So I basically will label this the IoT stack. It starts with more of the devices, right? I mean, above all the bits and bytes and actually the signals itself, but it's kind of really the physical layer, the devices. So those are these, embedded devices, actuators, Raspberry Pi, Arduino, how you name it, right? That can collect data. So that's the kind of fundamental things. And then in order for these devices to be able to be useful, is that it needs to be data will be collected by them and they will have to send the data somewhere, right? So it needs some way of kind of governing how to do it. And those are the protocol layers, which is the communication protocols, of which MQTT kind of belongs. We're going to talk about this protocol itself. So MQTT, and then there are other protocols that supports like IoT specifically, CoAP, and so Constrained Application Protocol. AMQP is Advanced Messaging Queuing Protocol. DDS, Data Distribution Service, and XMPP is the XML. I kind of forgot exactly, but that's actually a bit of an older protocol that's kind of XML based. That's why it's kind of start with the XM acronym too. And then there's also then the other protocols too. And it's kind of, I'm broadly grouping all of these protocols, right? It's essentially, if you are a networking enthusiast and specialist, right, you know that there are the 7 layers. So I sort of kind of group them all into this layer. So because I've been asked by folks that they were saying that, oh, well, it doesn't belong to the same. Yes, I agree. But now I'm abstracting out the whole communication protocol, the networking kind of aspect of things. So I kind of group them all in here. And basically, if we talk about MQTT, it is a TCP IP based protocol. So I kind of group them together. And then there are other protocols such as like the Bluetooth or the 6LoWPAN, and that's a kind of for low power kind of level of IPv6, right? And Bluetooth has its own kind of way of doing things too, has its own kind of protocol too. GSM, and then Modbus and BACnet, all of these. And in fact, some of them have not even worked with. I think they are more of the industrial layer kind of aspect of protocol too. And now then, if we move it up, right, beyond just the communication protocol will be the core platform. The platform provides you with more of the services that are needed on the infrastructure layer on that level, right? So it makes use of MQTT. So for example, like HiveMQ, where I worked at, right, they are into not just supporting the protocol, they also an IoT messaging middleware company, because they also have certain other kind of aspects of their products that support it, but primarily too, it implements the MQTT protocol in its broker. So I'd say the core platform will be something like the messaging middleware, the protocol gateway, the data aggregation layer, the storage, the filter, all of these kind of extends beyond just the communication protocol side. Now, if you kind of further move up the stack, then there are analytics platforms such as services that we will be needing now. We're going to start kind of making use of all of these data that we've collected various different ways. And for example, like services like geospatial thing, recommendations engine, reports, events, a lot of these two IoT data kind of applications actually for machine learning types of scenario. As we know, machine learning is involve a lot of learning systems, and basically it will learn and then comes up with the protocol that or kind of the application way of doing things, algorithms, right, as it needs. So machine learning, stream processing, all of these are on the analytics level. And then you get above another layer above will be the cognitive level that deals more with the AI, perhaps, right, artificial intelligence, voice recognition, interactions like gestures, spoken, all of these things, kind of more cognitive layer. And then if you go all the way up to in the whole bubble, the stack, then it will be, in my kind of view, I look at it broadly. I'm describing them into 3 categories. The consumer level of IoT, which actually relies on all of these things that are underneath, right? Or all, or I should say all or some of it, right? Not exactly everything. But the consumer level, for example, your home, right? You have devices, your dishwasher. For example, I have my dishwasher. In fact, I was just doing a load of wash, 2 nights ago, and then it's nice. I got an app that actually, when it's done, and the device, on my dishwasher will send me a notice that says, okay, it's dishwasher is done, cleaning all your dishes, things like that. So consumer, you can come into your house and it sends that you're home. It will turn on all the lights and all of these things based on different times of day. It will adjust the lighting, all of these things. So consumer level. And then there's also enterprise level that most likely you need it in your job, right? ERP system, marketing, sales. You can be leveraging on IoT devices. And in fact, any kind of IoT situation too is not just with the small devices anymore. You can be like machine to machine. Our laptops are a form of IoT as well, as long as your device is connected to the internet. So enterprise level. And then there's also industrial, which is like another growing kind of sector, because industrial involves more of, for example, connected cars now. That actually heavily makes use of protocols such as MQTT for communication, right? Your cars are all on the internet, like communicating, sending data to the server, getting processed, and where you are, when you're driving, it sends to a server and it sends you the location of where you are, things like that. Connected cars, manufacturing, factory floors, logistics, construction. Basically, the list goes on, and it's infinite. So this is essentially the IoT stack. As you can see, it's kind of taking over, right? The world, it used to be much simpler, but then now it's actually involves a lot of things. The benefits of it is that we all benefit from it from many levels of this kind of use of technology. Now, let me then turn to what is MQTT. MQTT is a standard binary publish subscribe messaging protocol, and is specifically designed for fast and reliable data transport between devices, and especially under very constrained conditions. Now, as you are aware too, there are many other PubSub systems out there, right? For example, Kafka is also PubSub, right? It's streaming. But the thing is that you wouldn't use Kafka to do your device thing because it's just the design is not specifically for MQTT. For example, too, now I'm at DataStax. I'm working with Apache Pulsar. So Pulsar is also a streaming platform. And unified messaging systems too. It's actually quite complicated in the sense that it also separates out the processing, the data collection part, the PubSub, the broker, but it's also stream things and transform messages. And you can certainly use that too. And people have used that. But the thing is too, I would say still MQTT would be more like the front end of your system if you want to like be using it in an IoT situation, right? So for example, things like you can still plug into Kafka into your larger IoT application architecture, because MQTT does the strength is that it kind of put it in the front end. You're collecting data from all of these devices, and as such, under very constrained conditions. Constraints, what are those, right? So it includes like unreliable network connectivity, very limited bandwidth, right? Limited battery power, and so on. You can have a very weak kind of a storage, right, of all of your power system that power your devices that can stay on for a long time, but you don't want to overwhelm your devices, all these communications. So MQTT is designed specifically for that. And then if your network gets cut off, that's the beauty too, is that the broker itself will take care of things. Yeah, don't worry about it. I will be responsible for delivering the messages for you. So that's kind of like MQTT in a nutshell. And it's really ideal for Internet of Things. And here it is. I'm actually borrowing a diagram from HiveMQ too, is how you can kind of represent them in pictures, right? It makes use of a PubSub kind of a way of doing things. So for example, you're driving a car, you have a speed meter, you want to collect the change of your speed, right, at different times and whatever it is. You actually then will have your system set up so then every time the data, your speed meter is collecting the data, it changes. So you want to track that and publish the data over to the broker. Well, think of the broker as like a post office, right? Kind of in a kind of a crude way of describing it. If I don't put in any kind of context of computing to make it easier to understand, it's like you want your messages to be delivered, but the thing is that you don't care who gets it. The point is that I want to essentially broadcast it out, sends it out. And the thing is too, there are also different levels of message guarantee, which I will get into a bit more detail. But as such too, it's not like you don't really care, but the point is that it's more like it's not my concern. My job, my publisher, I'm going to be publishing the messages, and I give it to the post office. In this case, is the in this case MQTT broker. So the broker would take care of things for me. Now, in order for me to kind of, I can't just be sending messages to all kinds. It's got to be some way of organizing them. So the concept is of a topic. So you basically want to label your messages, right? So topic too, as such too, and especially in Kafka, is kind of like a log, right? So kind of like that. So a log kind of set of messages, all these things. But anyway, topic is to kind of label your message, so that the broker will then know, right? Or actually, the broker will categorize all of your messages under this topic. So then it's basically the ones, if I'm interested in the messages, the consumer side or subscriber, I'll subscribe to that topic. So then when there are messages arriving at the topic, then the broker will take care of things and send it over to the consumer. So you see the kind of benefits of the PubSub kind of protocol, especially in today's world, in a very complex cloud native world, in which you can have, not just like billions, right? It can be like trillions and petabytes of data being sent all the time by so many devices every nanosecond, something like that. So many. So it actually helps too if you have this kind of an, architecture design, right? You kind of separate out the sender and the receiver. You actually help with scalability a lot. So that's the kind of beauty of MQTT. And a bit of a brief history. Let's get a bit into this too. So you may be wondering, well, how did it kind of come about, right? So in 1999, it was Andy Stanford Clark at IBM with his partner, Arlen Nipper. At the time, Arlen was at Arcom, and now it's actually Cirrus Link. Both of them were working on a client project, and they had to work with data that's actually collected from oil pipelines. And they were using satellite to do the transport, all of these things. But they realized too at that time, right, there was no proper protocol to handle that type of scenario, because the operating environment too was also very limited. There were minimal battery, and you can have like network bandwidth isn't very good, and it can be like unreliable. And then with oil pipelines and via satellite. So they came up then with MQTT. And because Andy he's still at IBM too. So MQ stands for message queuing. So that's a product that IBM has, right? Message queues, and still kind of running robustly today. And the thing is too, at the time too, he was designing it. He figured that, well, I kind of, not really exactly message queuing, but I kind of tag it on and call it telemetry transport. So MQTT, and that's what it is. So that's how it came up. Now, the thing is too, back then, right, it wasn't designed for MQTT, or actually I should say Internet of Things, because 1999, that was actually still the initial days of the internet, right? So there wasn't anything like Internet of Things, not yet, right? It's probably brewing. So they were like just addressing this. And so now that the world is very smart, there are lots of smart people like you and me out here, right? We kind of look at this, and then basically we're saying that, okay, then there's a rise of Internet of Things. We need to have some ways of connecting all of them. So there were then different organizations come out and kind of started like taking the MQTT and extend it further to make it kind of enable for Internet of Things. So as you can see, this is a timeline, right? 1999, MQTT got invented for oil pipeline and monitoring. In 2010, MQTT 3.1 opened as royalty-free protocol. And then 2012, that's when the Eclipse Foundation, the Mosquitto broker 1.0 got released. Then soon after that was 2013 when HiveMQ 1.3 got released. Now, bear in mind, I have to highlight HiveMQ. I mean, I kind of helped them out for a little bit. But I do have to say, I mean, HiveMQ is really this high quality product, right? They were like on top of things, and they were already involved in the early days of MQTT when it became more IoT kind of purpose. They were working closely hand in hand with the organization. Then eventually 2013 too, the world is realizing we need some way of governing this protocol. So they then essentially Oasis that kind of take care of things and kind of came, and then they formed the technical committee. So Oasis is the one that governs this. And then 2014, that's when MQTT 3.1.1 officially got released. And that's still the primary version that's, I believe, is being more widely adopted at this point. And then 2018 too, with all the Kubernetes, all of the cloud native, everything comes out, then MQTT 5 was officially got released. It wasn't all GA yet until actually 2019. And then at the same time, HiveMQ 4 came out during that time. And also it came out too with the official, like MQTT 5 kind of mostly kind of fully supported at that point. So that's kind of a brief history and a bit too about the technical committee. So as you can see, these are the companies today that are, they have kind of obligatory level of membership, right? They have voting rights, all of these things, which includes like IBM and software, HiveMQ, right? And EMQ, which is actually an Erlang implementer of the broker. Microsoft too is also kind of getting more and more kind of involved too with the IoT specification. Cisco, ThingStream, 9FX, and Solace. So these are like essentially the 9 companies right now that are kind of guiding this OASIS technical committee for MQTT. I'm sure too, maybe over time there may be more vendors or fewer that will happen too. Now then, let's get a bit then into the MQTT overview. So again, IoT messaging protocol, and I mentioned earlier too about the quality of service, QoS levels. Now, bear in mind too, it is actually very important in any kind of messaging systems. Think of the fact that when we're doing messaging, which is kind of not the same as what it's kind of we're more used to, synchronous kind of processing, right? So now just like a give of a bit of a comparison. So we're more used to thinking of things synchronously. For example, we're using the web browser, is making use of HTTP. It is a stateless protocol, but it's also very request response driven and also synchronous, right? So what had happened is that you send a request, basically to the client, to the request client, is like waiting for the response to come back. So it's a bit of a kind of wait, send and wait for things to come back and do some other thing. So it's sort of like it's already kind of built in a bit of a reliability or guaranteeing the message kind of delivery, because if you get lost, then and then you send it again, right? Now, the thing is with asynchronous processing, then it's different. It's more like, well, I'm publishing, as I mentioned about PubSub, you publish it. And if you don't do anything about it, unless you say, I don't care, which is QoS level 1, or actually level 0, I'm sorry, fire and forget, right? Then maybe you don't worry about whether, your recipient side gets it or even the broker gets it or not, that you don't care. That's QoS 0. Now, there's also QoS 1, which is like guaranteeing that it has to kind of deliver at least once. So that's QoS quality of service 1. And I'll go into a bit more detail. And then there's also QoS 2. So 2 is the one that says, I want only one, not more, not less. And so it involves a bit of work. So that's kind of like the 3 levels of QoS that MQTT supports. And then there are also concepts of retained messages. So essentially, as such, the name implies the messages needs to be retained, right, for whatever it needs to be done. And then there are also stateful and persistent sessions too that MQTT supports as well. So which kind of makes a lot of sense, because sometimes, it's easy enough to do things kind of stateless, right? So to speak, you send things out, you don't care, you don't keep track. It's a lot faster, lighter and everything. But the fact is we live in a stateful world. Everything needs to be persistent. You need to make a purchase. Some ways you need to have the purchase be tied into some other processing, things like that, right? It's actually, we need the stateful aspect of processing. So MQTT does provide that capability. And then MQTT is also very lightweight. It's very minimal overhead too. It basically is a binary type of protocol. So, all right, some basic features of MQTT 3.1.1. Publish, subscribe. So we'll take a look then first, right? I talk about the MQTT client and the server broker. So it's a kind of a, you think of like a sender and receiver. So the thing is, things kind of happen asynchronously. I just send, I don't wait, when it comes, it will come. I will send an acknowledgement if I'm expecting that, kind of like that. So as you can see, MQTT, there are like 3 basic commands too on the protocol level. So send or connect, right? Anytime you need to do anything, you need to establish the connection, connect. So the client sends things over to the broker. The broker will have to come back with an acknowledgement. Now, again, if you are not QoS 0, then you would be, the client would expect the acknowledgement. So it will be a connect acknowledgement coming back from the broker. Likewise, for subscriber client and publisher client too, you either subscribe to it, and then you want to hear back from your broker telling you that, okay, I got it, and acknowledgement. So that's kind of like the basic kind of, it seems like not too complicated, right? Kind of just send, and then you're expecting some response if, the QoS level desires it. Okay, so then now move over to the right side too, and just another example of an MQTT broker for a temperature sensor. Likewise, right? Your temperature sensor can be set up to send, kind of any kind of temperature changes. Perhaps too, you can set it up so then you can do periodic, like every seconds, every minute, and every 5 minutes to send data over to your broker. Broker is kind of like the post office. Will get your data, and essentially have the label, of all the topics with all of your messages. And then it's up to the consumer side that if they're interested, they can subscribe to it and and they will receive the messages when they arrive. The broker will be sending it. So that's kind of essentially the nutshell of publish and subscribe. Let's get a bit then into the packet level. So as you can see too, MQTT packet for connect, for example, it contains like a client ID, a clean session thing, and then also a field that's actually username and password is optional. I mean, but it's actually we should, or we should definitely have some level of protection in reality, right? But you can also have username and password too. But I would think that, if you specify things that are, open text like that, your packet needs to be encrypted, and which is something that MQTT does have as well. And then there are also last will in this particular example, that we have last will topic, last will QoS, and last will message, and last will retain. And the keep alive is essentially, it's just saying that, okay, I want to keep alive, I can wait up to 60 seconds in this case, in this example. And so now this gets kind of sent over to your broker. Basically, the broker gets it, and it's under normal circumstances, then it should send back an acknowledgement, the con-ack, back to your client, your sending client. So, and then the con-ack is essentially more like fewer, kind of, as you can see, just only two fields, the session present and a return code indicating 0, which means it's good. So, okay, and then, let me go back. Oops, okay. And now there's the packet then for publish and subscribe. So over here, MQTT packet publish, it contains the packet ID and the topic name and the QoS level and the retain flag, right? So indicated, do you want to retain this message? So we'll get into a bit of detail about that. And the payload is the actual data that you're trying to send over, right? You can see there's a lot of other kind of, a helper. They are not associated with your payload. And there's also an interesting flag called dup flag, so duplicate flag, right? Whether this is a resend, essentially, right? This is a duplicate. And then on the subscriber side, then it's basically the subscriber will have the packet ID, and then also then it will get for each topic you're subscribing to, it will be listed in there in the packet, and essentially too will also have it as associated QoS 1 and kind of apply for topic 1 and QoS 2 for topic 2, so on and so forth. Now, and I mentioned about will, so last will, right? So just think of two messages are like people, right? It's kind of in some sense, if you think of it like that. So it's basically your client, right? Your sending client will define what the will is LWT, so last will and testament. So it's up to, also is the responsibility of the broker to send a message, should the client dies, meaning that you can be like the client and server, not the client, publisher or consumer. It can actually, basically, it can suddenly like go away for whatever reason. But the thing is to guarantee that, you aren't truly, not leaving anything behind. You basically then want to enable the fields that, in your packet over here on the lower left side, right? It's last will topic, last will QoS, and last will message. And all of these you can specify there to indicate that you do have a last will. So should I die, right? So essentially, if it does go away, then the broker, that's what the broker itself is intelligence built in. In this case, it sends that, okay, that client dies, then I will actually push the data over to whoever has subscribed to it. And so it's using a real push. And it's basically what it is used for best is kind of implement some kind of on-off mechanism in a very safe way. And so it messaged too only when subscribing to the topic. So it only gets pushed if there are subscribers kind of subscribing to the topic. So that's the idea, right? Concept of the last will. And there's also a concept of retained message. So retained is interesting too. It's kind of essentially a last known good value. So the last message, right, will be stored on the broker side. So basically, I can be publishing different kinds of, messages over, publish it, sends it over the broker. But there's this last known good value. So the client decides if the message is retained or not. So I can kind of say that, okay, I have a bunch of messages I'm sending over, but I can turn on the retain flag to indicate so. And essentially, what this means is that future clients will get this retained message when subscribing to the topic. So it's basically like, okay, before actually I'm subscribing to some topic, and if that topic has been sent by a client that has the retain flag on, then I will automatically also, upon subscribing to it, I will be receiving that messages. So in some ways too, maybe there are circumstances in which you want, that, I'm a publishing client. I know everybody would need it. And so before they subscribe, or kind of I send the next message, this is my retained message. The last known good one will always be sent to the subscriber once they subscribe to the topic, even though I haven't had any new messages sent yet. Whatever is retained previously will be handled by the broker to send to the subscriber. So there are certain cases in which perhaps too for performance purpose, right? And that is kind of same messages. Everybody needs to know. Then you want to also send it first before, the publisher needs to kind of send it again. It's a bit of a performance improvement to it too. So. Okay, so now then move on to kind of the QoS, which is kind of primary thing in MQTT 3. Or actually not just 3.1.1, but it's an MQTT feature. 3 levels of quality of service. Again, QoS 0 is at most once delivery. It's like I publish once, I send it, that's it. I don't really worry about getting any acknowledgement. I just send it. And then there's QoS 1, and that one is at least once delivery. And then exactly once delivery is QoS 2. So we'll get into each one by one. QoS 0, that's actually the simplest in some sense because my client is going to publish. And I publish, and I basically said, I fire and forget. So over here, if you take a look at the packet, for example, packet ID 0, I have a topic name, my QoS is 0. The retain flag is false, right? In this case, it doesn't matter. And then also my payload, all of these things. So I send it, and I don't really expect a response. Is what it is. So, and let me kind of check to see if there are messages. Okay, looks like there's one. I'm sorry. I think I'm also wanting to make sure you could AMQP. Yeah, that's right. I'll kind of get to the AMQP. Thank you for asking, Nicholas. Okay, I just want to make sure I don't forget any messages. Okay, thank you for asking. Okay, so that's QoS 0. So let me go on to QoS 1. Here we go. QoS 1, right? Again, is at least one. So let's take a look. So my published packet comes in, and with the packet ID, the topic QoS level 1, and all these things, payload, blah, blah, blah. I sent it, and basically, okay, here's a scenario. Under normal circumstances, within your timeout, the keep alive timeout, in this case, say a minute or so. Actually, this example doesn't have it, but anyway. So before it times out, under normal circumstances, my broker will say, okay, I got it. So I send back an acknowledgement. All good, right? So this is like at least once delivery. Well, however, there could be scenario in which you time out before actually the broker can get to responding. So in that case, on the client side, I'm expecting some response, but I'm not getting the acknowledgement back. So in this case, let me send it again. So send it again, then I will set my duplicate, right? To say that, okay, this is a duplicate. I send it again, just in case the broker didn't get it. So in this case, the broker, let's say it receives it, but at the same time too, it got the second one, but the first one too could also, he could be processing, the broker could be processing the first one, but little late. So it's get the second one, and at the same time, he can be sending back both acknowledgement twice too. And so in that case, you are allowing duplicate in this case. For QoS 1 is at least once. You can be sending back both, but essentially too, you can have it be delivered twice, kind of like that. So that's an at least once kind of scenario, one or more, and not less, right? So, okay, so it guarantees at least once. Now, the thing is too, then there's also, what about sometimes too, we don't want data to be delivered more than once. It's exactly once. That's what we want, no more, no less. That's QoS 2. So in this case, as you can see, the handshake, there are 2 pairs of handshake. First of all, the client would send to the broker, publish QoS2, right? And then publish to the broker. The broker gets it, sends back a pub rec. It's kind of receive, right? So as you can see, the publish packet, normal packet like this, pub rec will come back with the packet ID indicating, okay, I receive it. In this case, the client gets it and then it says, okay, great, you got it. Wonderful. So here I am. Let me kind of do it again. It's a bit of a redundancy, you might say, but still it is necessary. Why? Because as you can see, it sends back another like pub rel, a kind of another one, right? Over kind of release over whatever. Actually, I didn't look up the REL, but the thing is, I sent back another kind of send over to the broker and telling him that, okay, with this packet, I receive your acknowledgement. So in that case, the broker gets it and said, "Oh, wonderful! You also you got my you got it my response the first time. So that's good. Here I am coming back to you with another packet and telling you, okay, pub comp is like complete. At this point, okay, all good. So as you can see, this mechanism will prevent any messages from being delivered like more than once, and in that case, because then you have this extra handshake to guarantee that, okay, well, if you get it already, then I won't send the second one. It is what it is. So even though something times out, and basically on the broker side would say, okay, I just want to make sure, I only take one of them, and so that's why you need that extra handshake to kind of make sure it's only once. So here it is, the 3 QoS level explained in a nutshell. Now, let me make sure the time. Okay, so how about then MQTT 4, right? You hear about 3, and then how about 4? So this is a bit of a trivial thing. So I was curious, so I looked that up. It's basically, if you look into on the packet level, on the connect message packet level for MQTT 3.1.1, there's actually a field, right, subfield called version that kind of maps to the your particular MQTT version level. So for MQTT 3.1.1, the version for this protocol name, MQTT, is labeled version 4. And of course, too, if your MQTT 3.1 version is 3, right? So then when it comes time, when they work on the next version, which is now kind of named MQTT 5, and it's basically looking at this field, they were saying that, well, 4 is already taken. So should we name it MQTT 4? That means you have to move the version for this particular field up 1 by 5. So they were like, okay, well, rather than being too confusing, let's have both kind of sync up together. So the MQTT is 5, and then the version number is 5 to kind of make it all kind of match to each other. So again, it's a bit of a trivial in here. Some key features of MQTT 5, now that I brought that up. So MQTT 5 is successor of MQTT 3.1.1. There's non-backward compatibility. And its first public release was in January of 2018, and the official release, more GA version, was March 2019. There are many new features, and also it clarifies the 3.1.1 specification. The goals of MQTT 5 is for enhancements for scalability and large-scale systems. So as you can see, the 3.1.1 version was released back in 2013. It's sort of like on the eve, right, of the kind of all of the containers, Kubernetes, all of these cloud native kind of revolution on the eve of that. So the MQTT 3.x versions weren't built as much in mind about scalability, but MQTT 5 addresses those. And also other things is kind of improved error reporting. And it formalized 2 common patterns, including like capability discovery and request response, and some extensibility mechanisms, including like user properties. You can kind of define them in your metadata kind of packet level. And then performance improvements too, and support for small clients. Now let's kind of get into just a few of these. I won't go into all of them because these can get quite complicated, but just to give you an idea, there's also this session and message expiry, and it's an optional part of the connect message too. So session expiry interval in seconds, and it's a bit more fine-grained control essentially. So it gives the broker the ability to expire session after the given interval as soon as the client disconnects too. So giving a bit more of that fine-grained level for broker to kind of expire a session. Should it kind of, a client already disconnect. So like that. And then there's also publication entry expiry interval is an integral part of a published message too. And it applies to online and queued messages both. So. And then I talk about the user properties. So this is about the metadata headers too. It can be part of most of the MQTT packets. It can be on the connect, pub, or sub too. And these are all encoded UTF-8 strings. And you can specify an unlimited number of user properties to your header, essentially. So it kind of makes it a little bit easier because sometimes you want to have certain kind of extra instruction, for example, or carry some properties right in your header, and so you on the receiving side can do some more things, for example. So give a bit more capability that the user or the application can have, right? Using this protocol. So. And then there's also concept of shared subscription. So it's essentially too, if you look up top too, there's a special syntax, kind of dollar share and ID, and my topic of these. It's kind of a hierarchical kind of indication of the subscription. And it's very useful for scaling out like back-end subscribers too. So this kind of particular kind of use case, in fact, is very relevant in like big data, huge volumes of data, low balancing client kind of scenario too. So you kind of then allow multiple clients share the same subscription. And essentially, too, here I highlighted too, is that supported by HiveMQ. If this feature is actually already supported by HiveMQ before MQTT 5 kind of became in the specification. And basically, too, HiveMQ already has it because them being in the technical committee, they actually introduced this concept and it actually gets incorporated formally as a specification in MQTT 5. So. And essentially, again, right, it's kind of helpful for doing scalability scenarios, upscaling, downscaling of clients at runtime. Is basically a very cloud native type of features. So it's kind of basically positioned MQTT, the protocol, ready for the cloud native kind of computing environments. So. Now, as such too, not all vendors have supported this because as such too, it is not a very simple implementation for this type of features. So, but again, MQTT 5 has it. Okay, so it's just a picture to kind of describe it, right? When I talk about the multiple, like broker, you can have different topics, right? And you can have that topic be shared among that topic subscription. The subscription itself be shared among different clients. So you can have different clients, but they are like, could be like the same, like kind of instances of the same kind of cluster within the same cluster too. So kind of makes it more scalable in this case. Now, there's one more that I like to bring up is essentially the request response pattern, but don't kind of mix this with the HTTP request response pattern because this pattern too is not on the protocol level. This is more on the business level. So it's kind of like a business acknowledgement type of scenario. So, so as such too, the request response is not the synchronous way of doing things. It's basically you want to correlate, right? Any kind of complex scenario in a business environment, you can have requests and response, but you want to have some ways of correlating all of these requests that comes out and the responses that needs to be kind of, again, like associate your requests and responses. So basically, if you look into here too, the client must subscribe to a response topic prior to sending the data to. So that kind of helps, right, on the business level, which in other words too, you do need to know your application quite well and know where to subscribe to some of these topics that are actually business level topics too. So that's in a nutshell, and this is just describe this particular scenario. So. I won't get into all of these details, but in summary, because I'm running low, kind of, I talk too much, so I need to be a little bit hurrying as I still want to show some things. So kind of a quick summary again. So as you can see, MQTT is really catered, really designed well for working with very constrained environments and Internet of Things connected device kind of scenario. Primarily, it's lightweight and is bandwidth efficient. So some more detail is that every message works as a discrete chunk of data, opaque to the broker. The control packet structure, you have fixed header, variable header, and a payload. Now, the fixed header is actually very small. It's only 2-byte fixed header. And there's also a variable header. Essentially, too, you don't need to include that if there's nothing you need in there. So it's very flexible, it's optional, and it's up to 12 bytes only. So as you can see, it's very lightweight. So if you think of sending messages, they are really light, right? Very efficient. And it's also very data agnostic. You can send all kinds of data, images, text in any encoding format, encrypted data and binary data, all of these, and is very kind of friendly to any kinds of data. And continuous session awareness, the persistent sessions that I mentioned about, as you can see, right, it's not just handling the messages, but it helps to, in certain kind of scenarios, you can persist all of these data. It stores messages, right? The broker, when it's offline, it stores it for you. So even if your network gets disconnected, your power failed or whatever, the broker already has that, kind of holds it too. QoS level 1, that kind of already helps with the session awareness. QoS, so is QoS 2. And retained messages, normal message with the retain flag will be stored and sent to new subscribers to his topic. Last will and testaments, and client can specify a message to send in case it disconnects, and gracefully, and that's with the last will. And very useful in IoT, especially over unreliable networks. Use cases then for MQTT, right? And as such, the topic is IoT. This is an IoT meetup group, so IoT, Internet of Things. Now, there's also then the industrial Internet of Things, which actually gets more into the manufacturing side of things, process automation, factory automation, all of these things too. It's basically poised to be ready for that, and it's already being used in a lot of factory kind of floors too, manufacturing environments. Then there's also Industry 4.0, which is like the next generation revolution of the industrial revolution that we're so familiar with. Now we're in 4.0. Basically, it kind of carries everything even further, is that we're not only dictated by one way of doing things, right? There you can have, creating solutions that are kind of composed of multiple types of technology, different kinds of protocol. How do they connect everything? This is in the Industry 4.0. And MQTT can participate in this kind of big party of many things kind of coming together. And MQTT does its own thing. Best, I think, is really on the front end side of stuff, collecting data from Internet of Devices. So industry verticals, I talk about in the IoT stack in the beginning. So automotive, logistics, manufacturing, energy. These are just some of the examples. Again, the list goes on and on. You can have many kinds of use cases to make use of MQTT. Consumers, smart home, lifestyle. You can have your fitness, right? Kind of measurement. All of these, you can make use of MQTT for the communication to your devices, right? And integration with other frameworks. So just a note about that. Again, I brought up too, you can kind of stream it, and I actually didn't put it here. You can have Apache Pulsar as well, and that's what I'm working on. Basically, you can build pipelines, right, of your processing too. You collect data, and it's basically data sent to more of the backend side. You can have Kafka dealing with that. And then there's also other brokers like Eclipse Mosquitto, Apache Vern, for example. Apache Vern, by the way, is implemented in Erlang. And then there are tons of many other kind of brokers too. Runtimes, you can have, if you're a Java person, it actually works well with Spring integration. I also did a talk with the Spring team at VMware too, and that's actually, you can work, Spring integration can work very well with an MQTT broker. Okay, and alternative protocols to MQTT. As such, you can use HTTP. Nobody stops you from that. But then HTTP is a very synchronous protocol, so doesn't scale well. So you probably don't want to do that. And then there's constrained application protocol. That one too, as such, right? It implies is for working under also very constrained environment. And as such too, it is also very efficient. The interesting thing is that it makes use of UDP, so user datagram protocol, and it's it's like TCP, but it doesn't have the guarantee part built in, but it's very fast. And then advanced message queuing protocol, I think Nicholas was asking about that. So that one, right? So you can actually use AMQP2, no problem. For example, RapidMQ. RapidMQ implements the AMQP, right? And there are also other protocols that also implement the AMQP protocol. I forgot, but RapidMQ is one of the implementations. Yes, certainly you can use that too. And then there's also object linking, embedding for process control unified architecture. OPC UA is more kind of come from the factory kind of implementation manufacturing too. Data distribution service as such is as a focus on the data, and is very much, I believe, is the XML driven types of protocol. And the other two is XMPP, which is Extensible Messaging and Presence Protocol. It's used extensively in instant messaging too. So that's XMPP, and also the Jabber, I think the implementation of it too. So these are just some of the kind of suggestions. If you don't like MQTT, you have other choices as well. Achieving IoT scale. So the point of using a pub sub such as like MQTT is really you're encouraging 2.7 million kind of publishers per minute, for example, or even more. But basically, these are some of the benchmarks we can get from some of the brokers. Topic subscription, you can have like 100,000 topic subscriptions in a minute, like all of these, right? X number of X, kind of 100,000 or actually million, right? Connected devices and 100,000 queued publishers for one queue. So these are kind of really like highly scalable, really fast kind of operations you're encouraging. So now, before I forget, I think I still have like 5 minutes or so. And I mean, before like giving some time for question, where did it go? Oops. Okay, here we go. Okay, this is that. Okay, I'll show it later. Okay, HiveMQ Cloud. So I just wanted to say that, yeah, you are kind of getting edgy now, or not edgy, but it's kind of like, oh, you're wanting to try something new. So over here too, if you go to hivemq.com there, or kind of cloud.hivemq.com, you get to this page, right? You can actually go here if you go to HiveMQ. HiveMQ Cloud will get you to this page, which is the HiveMQ Cloud for you to instantly sign up for a free tier cloud access. So you can kind of say sign up now if you haven't already done so, right? This is actually quite nice. So in my case, I have already signed in, so it brings me to my cluster. If you haven't, don't worry about it. It will just ask you they won't ask you for your credit card, which is great. So please kind of give that a try. And so you get your free cluster immediately. As you can see, gives you the URL, the port, TLS port 8883, or it also runs on the WebSocket. And then basically, I think invalid. I think because I started this a few days ago. But anyway, so if you go to manage cluster, then it will actually give you more details, right? Like I said, the WebSocket connection on 8884 by default, right? In this case, you can choose Amazon, AWS, or GCP, Google, or Azure for Microsoft too. There are 3 cloud providers you can do. It's free tier, and we give you a limited number, but it's actually very sufficient if you're learning and just wanting to do some basic kind of operations too. So this gives you that and access management. And when you first sign up, it will ask you to create your credentials. So that's very important too. So just keep it there. And you can create new credentials as well. So let's say if you have multiple clusters. Okay, getting started. This is the good part, the fun part. So you can actually go to this page, and this page will basically help you to start your first MQTT client. As such too, you have command line tool. You can do it command line, or using the MQTT FX GUI tool. There's also Mosquitto pub sub command line tool, and also our WebSocket, HiveMQ WebSocket client, Arduino too. And the other programming languages, as you can see, these are just a collection, but you can actually have any other, and this open source, right? There are also different contributions, but Java, Python, JavaScript, C, Go, Dart, these are kind of the fundamental ones you can use. And I think most of the folks are probably, I'm guessing, using Python and JavaScript and then Java. Is that correct? And maybe Go too. Okay, so you can actually try that, but let's kind of do this, right? Let's go to the HiveMQ WebSocket client. You can play around with it right away. So let's kind of go to one. Let's do that. Let's go back in here. If you go back to the main page, there's an MQTT public. If you go to HiveMQ.com, go to the MQTT top here, then go to the public MQTT broker. Essentially, you can try this out right away. You can click on the try MQTT browser client. As you can see, if you want to programmatically connect to it, it's broker.hivemq.com, TCP port 1883, and the WebSocket port is 8000. So let's do the MQTT browser client really quickly. Oops, this is not working. What is going on? Oh, I think it's just spinning. Oh, let me do it again. I hope it's not because they are doing maintenance. Sometimes they do maintenance stuff. So, okay, well, apparently they may be on maintenance right now, and I'm very sorry. And okay, so you know what I can do? Let me quickly show you something really fast too. I do have a quick client, right? And actually, that's something I was backing up. So very quickly, I know I don't have much time, so I'm just going to do this kind of command line way. So on my shell, right? I'm at my Mac and then opening up my bash. So as you can see, this is just a very simple, very simple, basic kind of example. JavaScript, right? Let me do it in JavaScript. So it requires Node, NPM, of these things. And I'm not using Docker version, just so you know. So this is the local thing. So now I will try to connect to the HiveMQ cluster. Let's see if that works. But for some reason, the WebSocket one doesn't work. So let's connect 1883 is the broker, not the WebSocket one. And then as you can see too, I was testing different things. I can have a local MQTT broker, or I can have my HiveMQ broker that's running on the on my cluster too. But right now I'm not using that. Let's just test something to the test broker. So as you can see, again, right over here, this one, I'm connecting. So all I'm doing is that I do a connect, and basically when it's connected, then I print out, indicating it is connected. And then if there's error, right, this is kind of asynchronous style. I basically saying that on error, I'm doing this. Some error, I'll print out the error code. And basically, too, I want to do a subscribe first, and this is starting my processing. It's not quite like processing, as you know, pops up is that you want to subscribe first, even though your data hasn't been published, because this is what it do, right? So the nice thing about MQTT, the HiveMQ, is that you subscribe first, even though the topic isn't there. I just indicating to the broker, okay, I am subscribed. I'm waiting for the publisher to start. Even your topic hasn't been created. So here we are. And then the next thing is that I do a bit of a wait in here, because as I was testing, I found out that it can happen so fast that before, when I'm subscribing, my publish already happens and I will never get my publish. So I basically wait for a little bit. Then basically I'll say, okay, welcome to my Twitch. Actually, I do things on Twitch. So in this case, I do a bit of wait here and there. And then this is the key. I'll just do my client.publish, and I publish to the topic called random, and basically say a test message, hello friends. And then I will just kind of wait, right? Okay, let's not wait for so long. Let's do this one thing. VI, let me kind of go in here. Actually, you know what? Done. Okay, I'm basically, I was just testing different things and making it longer. So let's kind of do it like basically nano milliseconds. So, what am I doing? I didn't mean to say quit, and I meant to say write it, right? So write, okay. Let's say, okay, right, WQ. Okay, there we go. So in order to run this, right, you see? Okay, I think you can see. Okay, so node example.js. As you can see, it's so fast, right? So that's how fast it is. So as you can see, I did a loop too, essentially. I sent it 10 times in the loop. So when you come into here, I already published, right? Or already connected. As you can see, things happen so fast. You see it's publishing before I say it's connected, but it's actually connected first. But like I said, sometimes the way it goes is that it print out kind of not in the right order. But as you can see, then I have a loop. Then immediately too, my client's already waiting there. So I'm receiving things. So test message, hello friends, like that. So, okay, so that's a really quick thing. And again, this one I'm connected to my broker. So it looks like the normal MQTT connection is good, but it's only the WebSocket one. For some reason, it's not up, that I couldn't tell. So, okay, so that's that. And then let me also quickly kind of show you some things. It's basically, okay, Eclipse, right? There's Eclipse Mosquitto too. That's an open source MQTT broker. And then also I wanted to show you too is the Eclipse Foundation also has a open source project called Paho. It's nice too. Now, every time you have a broker, then what do, right? You do need a client to help you to develop, has libraries for you to write code to that. So Paho has a good collections of different types of client too, as you can see over here. But I can also go back to my slides. Okay, here we go. Okay, so I did take a look at that. Eclipse Mosquitto, we took a look at that. Now, I wanted to point out Eclipse Mosquitto also has a public test server. And if you go there, you'll find is the test.mosquitto.org. It works kind of like the HiveMQ, the broker, the free one too, that you can use. Eclipse File download. So as you can see, it has so many different implementations of clients. So you can find what you will need from here, I believe. Most of you should be able to find. And it tells you what version that it supports and all the different features. So yes, please take a look at it too. So it gives you a lot of flexibility in that. So, okay, I think I may be running out of time, but I do want to let you know I have a Twitch stream, a weekly stream every Wednesday. So today, actually, 2 p.m., it's like today. No, today is only Tuesday. I'm sorry. So Wednesday, tomorrow, 2 p.m. But although I may be slightly late for tomorrow because I have some other engagement. But anyway, I will always be there, even though I'm a little late. So join me, right? And I have different things. I invite you onto my stream if you want to talk to. So it's really friendly. It's a nice community that I have. Also, I wanted to point out to you, please follow Frank Deporte. He's an expert in Java and the Raspberry Pi, and he writes books about it. And he has a company that he does a lot of fancy things with Raspberry Pi, with MQTT, with all kinds. He's a great guy. He also works on this other Pi4J too. He's an open source committer. So follow him. This is his website. And I have actually done an episode with him on Raspberry Pi just 3 weeks ago. So please visit that and watch that. He's done a lot of great things in there. So I'd like to invite you to visit that. Some resources. These are MQTT org, the MQTT ebook from HiveMQ. Those are really good starting materials. Mosquitto.org, Paho, and Oasis. So please reference that. And with that, thank you very much. I think I'm kind of on time. Thank you so much, Serena. Thank you. So thank you, everybody. And let me see if I kind of miss anything. And let me kind of switch back to my
Thank
personal.
you.
Yeah, thank you.
Thank you for the excellent presentation today.
Thank you. Thank you,
So
Serena.
just a reminder, if anyone in the audience has any final questions, please feel free to ask them in the chat or using the Ask Questions tab. Just while I wrap up quickly, so if you are interested in booking a virtual Eclipse community meetup yourself, feel free to fill out the form, which I will link in the chat. And let's just make sure that there's no other questions. I think we're all good, right, Mary?
Yeah, that's right. Oh, I do. Well, on the chat though, I see a
Yes.
question, Nicholas. I hope I addressed your kind of question, Nicholas, right, about AMQP. Yes, you can use that. I think there are differences and benefits. Let me just kind of quickly say, AMQP is originally kind of developed by JP Morgan, I guess, in the UK. So it's a bit more catered for the financial industry. But the thing is, with RapidMQ too, it's actually pretty efficient too, I'd say. But RapidMQ, it can be used for not just for MQTTs, put it like that. I think they'll be interesting. I didn't do an in-depth studies, but let me also take a look a bit more into if you use AMQP, what would be the benefits, right? But I'd say still, I think MQTT is just so lightweight, right? That's all it does. It's its life's mission is to do IoT, small devices in constrained, not just small devices, sorry, devices in constrained environments. So I think MQTT would be better. AMQP may be a bit heavier in that sense, is for other things too. Okay, and then Tahil, yeah, and okay, on ISO 7-level network model, MQTT is like level 3, like IP, or level 4. Okay, so actually, interestingly, MQTT is kind of considered on the 7 layers. They are actually on the application level, believe it or not. Even I thought would be TCP or IP, but as such too, because it makes use of TCP and IP on the 3 and 4, it actually get bumped up into the application level, but that's within the 7-layer stack. But of course, in the larger stack, then it's considered lower level, right? I mean, lower level in the sense it gets more detailed, dealing with the communication protocol side, but within 7-layer is on the top application layer. So okay, I hope that answers you. And can Kafka, Mohammed, thanks for asking, can Kafka directly support MQTT and act as a broker in the open source version? You actually asked a really good question. I have not seen any implementations or people using Kafka as an MQTT broker. I think that's actually, it is possible, I'd say, theoretically, but I'm not sure if we want to use Kafka for MQTT because it doesn't take into account, right? Again, the constrained kind of scenario, even though, well, I guess on the broker side, it does a lot of the storage thing. And actually, by the way, too, if you use Kafka, right, that's the thing too with Kafka. I think as you may know, if you get into bigger kind of implementations, because of the way it handles the data, it's all like the broker handles all the storage itself. It just may not be as scalable in that sense. And also the partitions and how you have to kind of know ahead of time how many, partitions you support, how many clusters, all of these things. Now, unlike Pulsar, right? Pulsar actually is natively built in all of these things. So you might actually want to consider MQTT using it on Pulsar. I like to suggest that. I haven't done it yet, but I like to try that too. So, but good question, Mohammed. Okay. And Tahil. So application level protocol level 7, like HTTP. Yes, that's correct. Yeah, exactly. The level 7. Okay. Is there any scalability? Mohammed also asked, scalability HA limit in HiveMQ community. Um, Good question. I think the community edition shouldn't have any kind of limitation on the scalability side. I do not believe it, but I can verify with the folks at HiveMQ too. But that's also a good question. Yeah. Okay. Great. Yeah. I think I answered most of your question. And oh, and Mohammed said something like HiveMQ documentation MQ standard is the best. Yeah, that's right. Yeah. I still, I mean, I work there. I like the company. They're really great folks too. So yeah, community meetup and oh, okay, great. Yeah. Thank you. Yeah, thank you so much. And I have my Discord link too, right? Let me kind of shrink myself up, then you can get my Discord, yeah, better, right? So okay, so that's my Discord link. So I invite you, if you're interested in further communication and just have more conversations and coming to my Twitch too, please also join my Discord server. I can have more conversation with you too. So yeah, and then Mohammed says enterprise offering on Kafka Connect, but not sure. Yeah, that is very true. HiveMQ is not all open source. It's only community is the free version, but otherwise you do need to pay. So yeah. Okay, great. Yeah, you are welcome. Thank you for asking those great questions. Thank you so much. Yeah, thank you. Discord. Oh yeah, let me add it in the chat, right? Okay, let me do this one thing. I do have to escape here, and then I can then. Oops. Okay, let me do this thing. Copy it in the chat, right? Okay. Okay, I think I got it copied. Yeah. Okay. Great. Yeah. Good idea. I
Perfect.
didn't think of it.
Awesome.
Yeah.
Thank you,
Well,
everybody,
thank
again.
you. Thank
And
you so much.
we will see you soon. And don't forget, if you're interested in hosting a chat, feel free to fill out the form. Have a great day, everyone.
Thank you. And thank you,
Thank you.
Serena, for hosting. Thank you.
My pleasure. Take
Yeah.
care.
Have a good
Bye.
day. Bye bye.